Binomials giving you a hard time? Let me help you. Basics first. So NCR is used to find the coefficients mainly, and N is your power, which is just this, and R is your index. I'm going to say index because it starts from 0. So the first position is index number 0, and the second position is index number 1, and we're going to use the index. Now, when you want to expand NCR, you're going to write it as n factorial over r factorial times n minus r factorial. That's it. So, for example, say you need to find 7c4. You're going to write that as 7 factorial over 4 factorial times 7 minus 4 factorial, which is just 3 factorial. So, let's expand it. We're going to get 7 times 6 times 5 times 4 factorial, stopping at 4 factorial because the denominators cancel out. So 4 factorial times 3 factorial, these cancel out. 7 times 6 times 5 is 210. 3 factorial is just 6. Therefore, this is equal to 35, and that's what 7c4 is. That's how simple it is. Now, to make your life easier, there are a few shortcuts or generalizations you have in the NCR notation. So, number 1 is that NC0 is equal to 1, always. Number 2 is that NC1 is always equal to n. Number 3 says that NCR is always or can be equal to NC n minus r. So that means 7c4 could be written as 7c3 as well, because 7 minus 4 is 3. And finally, number 4 says that NCN is equal to 1 as well. Sorted? Okay. Now, I'm gonna get all of these away. Moving on to our general term. Now the general term is tricky because it's long, but once you get the hang of it, you can do it quickly and efficiently. So let's breeze right through it. Now I'm going to call the general term TG. TG is going to be equal to NCR times a to the power n minus r times b to the power r. That's it. You can use this formula to find any term in any binomial expansion. That's it. That's all you need to know. Okay? Now moving on to our second key factor you need to know when you're solving binomials is that you have to know what to do when the b value in a plus b to the power n is lesser than 0. And when I say b value, I mean the modulus of b value, regardless of plus minus. In that case, there's a special expansion that you're going to use like this. So when modulus of b is lesser than 1, you're going to expand it like this. First, you're going to start off with 1 plus nx, or in this case, it's going to be nb, nb plus n minus 1 b squared over 2 factorial plus n minus 1 times n minus 2 b to the power 3 over 3 factorial. Now I hope you're seeing a pattern because I don't want to write this forever, but it's going to go on until n minus 1, n minus 2, n minus 3, n minus 4, and b to the power 3, 4, and 5. And the factorials on the denominators keep increasing as well. So that's all you need to know in this area. But be mindful if they ask for a question as to why you're using this, say that the b value or the modulus of b value is less than 1. Just, if you write this, you're going to be sorted. Okay, moving on to our practice questions. So this question says that in the expansion of x plus k to the power 7, where k belongs to real numbers, the coefficient of the term in x to the power 5 is 63. Find the possible values of k. So to make it easy on all of us, I've written the general term formula on the side, which is NCR and all of that. So let's rewrite that using the terms they've given us in the question. So 7CR times x to the power 7 minus r times b to the power r. Notice we don't have r, and also notice that they say possible values. This is important because they're asking for more than one value for k. Okay, now the second step is finding the power of the x in the coefficient. So they're asking the coefficient of the term in x to the power 5. So that means that this little thing needs to be equal to 5. So let's equate that to 5. Then we're going to get r as 2. Now we can rewrite this completely as 7c2 times x to the power 5 times k to the power 2. This should be k, sorry. Now I'm going to rewrite this in a way that you'll understand better. So I'm going to write this as 7c2 times k to the power 2k squared times x to the power 5. Notice that this whole box right here is the coefficient of x to the power 5. Now if that's the coefficient of x to the power 5 and the coefficient of x to the power 5 is 63, that means that 7c2 times k to the power 2 is equal to 63. That means that 21, which is 7c2, I'll make it easier for you, 21k squared is equal to 63, therefore k squared is equal to 21. 3. 63 by 21 is 3. That means if I'm going to square root both sides, I'm going to cancel out the square. That means k is equal to root 3. Now that's one value. How do we get possible values? Well, that's the important part, because when you're rooting something, there always is a plus and a minus. So one possibility is plus root 3 and the other one is minus root 3. Those are your values. Okay, moving on. Question number 2. So question number 2 states that consider the expansion of x 8x cubed minus 1 by 2x to the power n, where n belongs to positive integers. Determine all possible values of n for which the expansion has a non-zero constant term. That's important. Before that, I'm going to write our general term, which is NCR times n a to the power n minus r times b to the power r. And notice that they say non-zero constant term. So let's break it down. The expansion has a non-zero constant term, acknowledging its existence. A non-zero constant term, meaning that it's not zero, and a constant term is always the term which has x to the power 0. Got it? Done. So since x to the power 0 is just equal to 1, they're just asking for a term without x. That's it. So let's rewrite this. We're going to have NCR times 8x cubed to the power n minus r times minus 1 by 2x to the power r. So let's distribute our powers and simplify our whole numbers to make it more simplified and simpler to understand, NCR cannot be simplified. 8n minus r times x to the power 3n minus 3r, because the power gets produced, times 1 over 2r times xr. Now, I'm going to take the minus over to this side, and let's see. We can simplify 8 to have a base 2, so that will be NCR times 2 to the power 3n minus 3r times x to the power 3n minus 3r times 1 by 2r and xr. Now, since 2r times xr is in the denominator, that means the x values on the left hand side, meaning these values, are being divided by these. And when these values are being divided, their powers subtract. So that's going to give us a different equation. So now we're going to get NCR times 2 3n minus 4r times x to the power 3n minus 4r. Now, they're asking for a non-zero constant term and the values of n. And we know that the constant term has an x value of x to the power 0. Now, we have an x over here. So that means that 3n minus 4r has to be equal to 0. Therefore, 3n equals 4r. Therefore, we're going to keep n with 3 and we're going to take 4 away from r. Then we're going to get 3n over 4 equals r. Now, can r be a fraction? Can an index be a fraction? No. No, it cannot. So, n should be a value that cancels out the denominator and makes r a whole value, a positive integer. So, obviously, n can be 4. N can be 4 because 4 and 4 gets cancelled and it's going to be 3. Can n be 5? No, it's not dividing properly. 6? No, again no. 7? No. 8? Yes. Well, it can be 8 as well. So, if you're noticing a pattern, the next one's going to be 16, 32 and 64 and so on, and it's all multiples of 4. Therefore, the only answer to this question is that n is equal to 4k, where k belongs to 7 positive integers. Now, we have to state it for a method mark and the answer mark because they will not assume what you mean by k. So, that's it for binomials. Practice, take notes, and please don't forget this.